So how do we write Lewis structures? These are general instructions. And this process can be a little frustrating because I can't give you a set of instructions that if you follow them every single time it'll work out. But much of life is like that. So we need to have a general idea, and then we just kind of have to be flexible as we go. So the first thing you want to do is get the correct skeletal structure. So this is how are the atoms going to be connected to each other. And when you get larger molecules, sometimes there's more than one way you could put them together. If you only have two atoms, it's easy because they've got to be connected to each other. Hydrogen atoms are always going to be terminal. And what that means is the hydrogen atom can only form a single bond, and so it can't be in the middle of the atom. It's always going to be terminal on the outside, at the end of the line. Typically, we put more electronegative atoms in the terminal positions. The less electronegative ones would be in the middle. So we're going to start like that. Then we're going to calculate how many electrons do we have to deal with. So we're going to look at the valence electrons from each atom that's in the molecule, and we just add them up. If we're doing an ion, we have to consider the charge. If the charge is positive, that means we lost electrons. If it's negative, it means we gained electrons. Then we're going to spread the electrons around, giving octets to as many atoms as possible. So putting dots around. And of course, hydrogen only gets a duet. And then if you run out of electrons, you may need to form double or triple bonds. So those are the guidelines. Let's practice. So write the Lewis structure for carbon monoxide, CO. Well, the skeletal structure here is fairly easy because we have two atoms. They must be connected to each other. There's no other way around it. Then we want to figure out how many valence electrons do we have to work with. How many does carbon have? 4. And how many does oxygen have? 6. It's in group 6. So we have a total of 10 electrons to deal with. So you have to have at least a single bond between the atoms to connect them. And a single bond is 2 electrons. So that's 2 electrons. And then I'm just going to start putting them in pairs. So that's, I've got 2, 4. Let's see, those are too big. Make that a little smaller. It's not much smaller. So 4, 6, 8, 10. And there's no one correct way to do this. Just start spreading them around. I've accounted for all the electrons. Do those atoms both have octets? No, they don't. So when there's not enough electrons, that means we have to share more. So I'm going to take one of these lone pairs and share it between those two. So I don't know, I'll take the one off the carbon. Take this pair, and I'm going to make that into a bond. So instead of it being a lone pair, it's going to be a bonding pair now. So now we see, well, what do we have going on now? Well, we've got 2, 4, 6, and 2, 4, 6, 8. So the oxygen's happy, but this carbon isn't. So we need to share even more. This is the one that has enough. This is the one that doesn't have enough. So we're going to ask the guy who has enough to do the extra sharing. So I'm going to take a lone pair from the oxygen and make that into a bonding pair. And now when I count things up, everybody's got 8. Sometimes when you're doing this, things get a little messy. You should do this in pencil. And so you kind of do your work over here, and then for your final answer, you copy it down nicely, right? So I might write this over here. Stupid pencil. With 3 bonds there. And then I'm going to put the electrons, the lone pairs over there. And that's a good Lewis structure. Exactly where you put the lone pairs doesn't matter. If you put them on top of the oxygen, on the bottom of the oxygen, that's fine. I just like to make it look symmetrical. Any questions? Yes?
Is there a way for them to violate their own count of the valence electrons? Or just for carbon?
So we're not concerned with how many valence electrons carbon had here. We're just trying to get an octet for everybody. Yeah. We'll deal with that other thing later. Okay? Any questions about that one? So let's do H2CO. Now this one, we kind of have to figure out, well, how are we going to connect these to each other? The hydrogens have to be on the outside. So maybe let's start with the other things. Put the carbon and connect it to the oxygen, and then we have to figure out, well, how are we going to connect the hydrogens? Well, how about just put one hydrogen there and one hydrogen here? We will learn a method that'll help us predict how those are going to be connected. But for now, we'll try it and see. So then we have to add up how many electrons do we have to work with. Well, I have two hydrogens. They each have one valence electron. And I have one carbon with 4 valence electrons and one oxygen with 6 valence electrons. And so I believe that's 12. 12 electrons in my structure. I already have 2, 4, 6 accounted for as bonds. Two, 4, 6, 8, 10, 12. I ran out. One of the nice things about the octet and top, bottom, right, and left is if you have a bond or a pair on each side, then you know it has an octet. So I can look at this oxygen and know it has an octet without counting. I can look at this one and see that it's missing something down here and it doesn't have an octet. So we need to share more. The oxygen has the octet, so let's take one of its pair of electrons and share with the other one. So I'm going to take that one down there and bring it over here to share. And now I've got 2, 4, 6, 8, 2, 4, 6, 8. Carbons and oxygens have the correct number. Any questions? Let's do another one. So this is a polyatomic ion. It's got a charge, a -1 charge. So we'll have to take that into account when we count up our electrons. Here again, we just have 2 atoms, and so how they're connected is pretty straightforward. They've got to be connected to each other. When we count up electrons, chlorine has 7 valence electrons. Oxygen has 6. Oxygen has 6. And then the -1 charge, does that mean I have an extra electron or I lost one? I have an extra electron, so I need to add 1. So that gives me 14. Okay? I already have 2 being taken up in that bond. So then I start counting 4, 6, 8, 10, 12, 14. Oh, good. I had enough. The chlorine and the oxygen both have octets. I'm not quite done though, because this has a charge on it. And so I need to put brackets around the whole thing and put the charge on the outside. Any questions? On Mastering Chemistry, it doesn't have brackets for drawing Lewis structures. And so you do have to put that negative charge somewhere, but it won't let you do brackets, so please do not text me and ask me how to do brackets. It doesn't do brackets. So what I would do is I'd say, well, chlorine and oxygen, who's more electronegative? Not obvious from the periodic table, guess and stick it on 1. So, remember the name of that ion? Hypochlorite. Chlorate is ClO3-. We have chlorite and hypochlorite.